Mr. Casino. Bet you're like, finally. I know you've been hanging in there off a ledge here recently, man. Just about to give up on the old GK, which is understandable. Good God, nobody should have to wait on a dang 2-pill repair this long. Whew. Once I get the last bit of these, I probably got 6, 7 more repairs left here, period. I remember one time there was over 80, 90 amps here for repair. God. There's only about 6, 7, maybe 8 at the most left. They're all out here too. And boy, good God, I can't wait to do things differently when I open my shop back up. But anyway, man, read everything you want done to this. You want this bias for sideband, and I will concur on you at it doing about 80 watts. That's just about what it's doing over here on my end. So this is a 100-watt slug. So you are looking at the bottom scale. Oh dear. Excuse me. Top scale. What am I saying? Top scale. Need the 100-watt slugs to 250. Oh dear. So that is about 75. Oh yeah, about 75 watts peak. So I don't know why I thought I was on the 100 watts. That's because I just had a 100-watt slug using testing a new rig I just got. I'm getting back on the air, man. Easing myself back on the air. I ain't been on the air in about 3 years, man. Got that too backed up. So anyway, man, here's what I say we should do. Since you don't exactly have to have that preamp, man. Honestly, the preamps in these things are not worth much. I say what we do is just go ahead and remove the preamp and use this relay over here for your sideband voltage, for your key-in voltage for your sideband, your bias, your bias. And what I think we should go ahead and do then, this is what I always do to these. I don't like the idea they bring the power wire in like this and let it flow through a switch to power the transistors. You can have some voltage drop that way, this and that. It's best to take this right here and bring it in and put it straight to the back of the transformer, and then run a small wire from the transformer over to the switch for the relay. I'm not sure why they never did that. I always modify them to do that. And I always take these big honking diodes off and replace them with a modern day diode. And I think we should just go ahead and take these old weak low wattage transistors. I got a whole bag of these things, man, that I've removed out of prides and stuff. What are they, man? They're CTC 3008s. CTC 3008, some no-name transistor used back in the days. I see them in a lot of older amps like this. So we'll put some modern-day transistors. I ain't quite figured out which one. I know you said it's most of this stuff, so you're just going to trust me just to do what I think's best. We'll either throw some 2879 HGs in there for you, or maybe some 454, something like that. I'm going to look through and see what I got hanging around here. And I am going to go ahead and remove both of these transformers. And the transformer's been in the box this long, 30 plus years. The inductive properties could be a little off, man. The permeability could have changed. And plus, I'm going to put different transformers anyway to accept the transistors I'm putting in here. So basically what we're going to be doing is just removing this whole amp section right here and building you a new amp section, putting you the bias in here, and tuning that bad boy up for you, and of course getting rid of all these trimmers. And we will check out the SSB delay for you. The SSB delay appears to be working, but I'm not going to be leaving a 35 your electrolytics in this box. So I'll be removing that, and maybe a few other things. Yeah, we'll go ahead and solder that ground wire down for you a little better. I may actually take that ground wire and run it over straight to right here on the board. We'll see. We'll see. But this wire's thick enough. I'm not a big fan of this right here. I may just go ahead and drill this hole a little bit bigger and put a strain relief on there, and just rerun the wire. And I was going to ask you, man, reply if you don't mind. Do you need this fuse right here? The reason why I'm asking, if you have a fuse under your hood, you don't need this fuse. But if you don't have a fuse under the hood, this needs to stay here. Just let me know about that. I like removing fuses on amps because it helps with the current flow and everything, as long as there's a fuse under the hood. There's got to be a fuse under the hood. I know guys that don't. They keep bolt cutters in their car. If something happens, they cut the wire. But anyway, brother, here's all I ask. As you can see, your box is sitting on this table right now. Let's see if I can prove to you what the date is here. So just so you know, I ain't pulling your leg. It is the 25th, okay? I gotta go on vacation, man. I got kids. I'm only gonna be gone for 3 days. When I get back, this amp is staying right here. As soon as I get back, get this done, get it out of here. Now, you've been waiting this long. I don't think it'd be that big deal to wait three more days, 4 more days on it at the most. Once I sit down and get to this, it shouldn't take no more than just one sit down to do this. It ain't gonna take long to remove these parts on here and do what I need to do. I'll get in here and clean it up for you and all that good stuff. And of course, I'll give you a little discount, like I have to do for everybody because of the wait time. Get back to me, Mr. Casino. And by the way, we are going to the casino. Going up to Cherokee, North Carolina. Mr. Gatekeeper. Some of them call me Slow Keeper, and some of them even call me Smell Keeper. Because I be slow, they say. Buy an amp from Gatekeeper and hope you get it before you die. That's terrible, ain't it? Alright, brother. Get back to me, man. Let me know if you find one out. I hope you are. This will be an easy build, man. This thing's in great condition, by the way. Great condition. Got some holes on the heat sink. People do that to mount them and everything. But other than that, great. Yeah, I see the screws back here are rusted. I think it'd be best I go ahead and remove them and put stainless hardware in there for you. That's just what I do, bud. And also, there's nothing coming from the SOs to the board. But a lot of them, the reason they didn't do that is they relied on these screws right here to make good grounds. If you can see, this screw's oxidized. So this screw's oxidized. It's not stainless hardware. So it's hard to say. So, all right, bud. We'll see you, man. All right, brother. We got this thing pretty much almost finished up. Getting this thing fine-tuned for you. There's all the parts. I'll put them all together when I get done. But basically, this is something new I'm starting to do to really fine-tune to get the input down as low as possible. Because the HGs can come a little different here and there on the inputs. But anyway, man, this thing's tuned great. Here's the input reflect. Oh, yeah. It's tough to get a 2-pill that low. It really is. Oh, yeah. You gotta know what you're doing. 250 watts slug. That's how you know when the 2-pill's working. When you can hit a 250, right there at the slug, at the end, you know the 2-pills are doing what they're supposed to be doing. We are Class C though right now. Okay, we are Class C. I've got the bias circuit right here, and I need to do some adjustments to it. It's a little high right now, so I'm gonna need to get down there and put my variable pot on there and get that adjusted at a good level for you. And she should be doing about 80 bird right now, which is what 22879s do on my bench radio. And that is on 13.4. I usually tune around 14.5, but I got it on 13.4 right now because I'm testing the bias. I like the way you do these old RF circuits back in the days. Take a little sample of the output and shunt half the signal to the diode. Shunt half the signal to the ground. Leave a pulsating DC signal left over on a high frequency, a higher frequency, and it's enough to light the LED. You'll see some of them use like a 220 ohm resistor instead, and I was kind of worried that this may blow the LED since this amp's doing a lot more power now, especially when we get it all done and hit it with a bigger radio. You've pretty much almost doubled your output now once this is all said and done. Anyway, we got that relay keying with this one now. Since that's your bias relay, okay, you will notice that both of these are going to turn on now with your power, okay, because we need that to hit. We need that half power when that has power, so you're going to see that happen, okay. So just remember, that's why this is going to be coming on, because we're using the same circuit path for that. So that's the only reason. All right, man. When I come back, we'll have all these three trimmers mic'd in and have the bias figured out. Still need to see about this right here to see if that's, well, I'm going to be replacing that regardless. So I need to get that and figure out what size cap to put that on there for you. And I'll come back and I'll explain everything I did too. I'll be back. All right, brother, we got this thing done, sewed up, and finished. Here's all the parts that came out of it. It's been a little while since I've done a repair / rebuild like this. You gotta get creative with these older amps. You'll see a lot of these little small wattage transistors in older amps. Not sure who made them. CTC. So anyway, brother, I've got to tell you, man, I absolutely insanely love this wire. This wire is just as flexible as any mobile audio wire you'll see, with one difference. Here's a piece right here, okay? Soldering iron. Go ahead and blast that thing up to 800 degrees. Let's get some good solder on here so it's real nice and hot. This is why I love this wire. Look at that. I'm pushing on it. Look at that. No burn. No burn. Yes, this wire is a bit expensive, but I absolutely love it. The only reason, honestly, the only reason I used it with this box, I kind of bought this to use in bass amps and stuff like that. But the main reason I used it is because I didn't have a lot of space right here. Didn't have a lot of room. I definitely didn't have no room to run no 8 gauge in here, which, you know, is overkill anyway. So, and I did not have, I had some 10 gauge black, red wire, excuse me, but I did not have any 10 gauge black wire. So that's the only reason why I did use this. This right here is silicone wire, 200 degrees Celsius. 200 degrees Celsius, super worm, and oh my God, I love this wire. It solders great. If you notice, I don't have to use any heat shrink like you'll see me use on some of the other wire, because the main reason I put the heat shrink on the other wire is to kind of help it while I'm soldering it, help it not split and stuff like that. So anyway, we technically just built you a whole 2 transistor amplifier here. Guess you can just call it a GK200. And you wanted it biased. So what we did is we removed all of the preamp devices. By the way, this right here was blown. We removed all of the preamp circuitry and used the preamp's relay for the bias. So here's your bias circuit right here. Simple voltage divider circuit. Looks a little different some of the bias circuits I've done in the past, but it's basically like a simple voltage divider circuit like you'll see Texas Star using. And then that resistor right there is your shunt resistor right here going to ground. And I'm going to go ahead and tell you, very seldom I'm able to get a 2 transistor amplifier like this to have perfect input. I'm talking about perfect 50 ohms input impedance. All the power is making it into the circuit with none going back. Very seldom. You'll have a little bit. Look at this sucker. Power is on. We're on 15 volts. 5-watt slug in reverse. You can see that thing moving. Go. I mean, you get a teensy movement, but is it even moving past the 1 hardly? Go. That don't happen much. But the way I was able to acquire that perfect tune is we had 4 trimmers in this bad boy. Do we have 4 or 3? No. 1, 2, 3. We had 3 trimmers total. I'm going to start doing that more with the HGs. But went ahead and reconstructed a couple of things. Instead of the wire like it was coming all the way to the switch and having this switch, having all the current flow through this switch, that's not really a good idea, especially for upgrading the transistors. These transistors are now more powerful than the ones that were in here. You don't really want that flowing through the switch if you can't help it. So we went ahead and put you a hot bus down here. So now that comes directly down to that hot bus. And then we ran a wire from there up to the switch to carry on the power of the LEDs and both the relays and your bias. Okay. Went ahead and of course added you some feedback circuits, or some people call them flybacks. Not too sure where that word came from, flyback, when it's the proper name that you'll see used in a lot of Motorola bulletins and stuff like that is feedback. Because you're balancing the circuit out by giving a little bit of negative feedback, a little bit of the input into the output, vice versa. That's why it doesn't matter which way these are faced. Okay, you could turn around the other way and it's still going to work the same. This thing turned out great, man. I was very surprised. The tuning of it blew my mind. That's what I'm saying. You can have 2 or 3 amplifiers and the tuning can completely be different. This is my little book of tunes. I just record tunes while I do it for mainly reference, research and stuff, to look back on certain things. And I'll write other people's tunes in here too. I like studying people. So you get to where you at, man. You study, you look at your surroundings and study. Alright. I like writing all kinds of tunes in here. There we go. Look at this tune right here. Could you build yourself a 2-pill in an ICA cabinet and put these exact capacitors there and work good as this? Absolutely not. Absolutely not. Why are these numbers off? I mean, look at this. We got 133.6 on the output and 131 on the input. This is foreign to me. That ain't like if I build a 2 transistor amp and an ICA cabinet, this is not what the tune's going to come out. But why? Why is that? But why? You got to look at what's in front of the input and what's behind the output. What's different than what you normally do. We can see right here what's different. We have no 50 ohm coax feeding the input. Coax has capacitance. If you look at a coax, it's a capacitor. What is a capacitor? 2 conductive surfaces insulated from each other. That's a capacitor. So this thing has no, everything's so short it doesn't need it. So that's going to change the input tone. Definitely. Okay. And the output. The output is flowing on a trace right here up to the relay. Okay. And you have the relay itself. All this stuff comes together as a whole when it comes to tuning things. And then you got the transistors. This is the best thing we got right now. Widely available for a good price. And I think back and I'm so glad I contacted HG the way that I did, and I didn't do it with a, what's the word, an egotistical way. I could have said I wanted my transistors made. I wanted a GK100, a GK150, but I didn't do that. I wanted to do this for the actual hobby, so we all could possibly have a transistor that we could use and somewhat trust. And they're not perfect, by no means. They're not a Toshiba, by no means. But there's something we can work with, and something we can enjoy using, and something we can make power with, for sure. And they do change a little bit from lot to lot. That's why it's. I'll tell you what, these HGs will keep your tuning hat on. I'll tell you that. It'll make you sharpen your tuning skills, no doubt about it. I did change a little bit of stuff. There was a tuning cap. They had a shunt cap from the input here going to ground. I went ahead and removed that. There's no need for it. It was just part of the tuning system they had with the other transistors in there. And oh, I almost forgot. These were in there, and a lot of them have become oxidized, as you can see. And I didn't want to trust that. So what I went ahead and did is put all stainless steel hardware, number 4 hardware, holding the SO239s. And if you look down there, I put ground lugs on each one. All right, I see this phone's about to die. So, and we replaced your capacitor for you. You got a little bit better of a delay now. All right, 4-watt radio, or 3-watt radio, excuse me. $250-watt slug, go way in the corner. 100-watt, oh, 100 bird. Now, we'll tell you something pretty neat. Before I biased it, because I always class C and then tune, and then put the bias on after I check the bias, make sure the bias is correct, and then retune again. And the box was doing 80 bird class C. Once I biased it, it increased 20 bird. We won't get into why that is. It's just a neat little thing. A neat little piece of information for you. Yes, it does become less efficient, but it becomes more linear, and it takes a little bit less drive to get it going. All right, we got a 500-watt slug in now for peak. Go right there about 330 or so. 330 or 350? Yeah, about 330. Go real low dead key too, just to show you. I had somebody mention that the other day. Very low deck key. I'm only deck keying. Well, actually, my deck key's pretty low right now. I just remembered I need to turn that thing back up to a watt. Oh, that input is beautiful, man. That's what you want to see right there. That's tough to do at times. I ain't gonna lie to you. That is tough to do at times. All right, man. Let's go ahead and do this. If this was my box, this is how I would run it, bud. Is the way you see me running right here. This radio is doing like 16 to 18 peak. This thing will last you forever if you run it like this. But of course, it is a high drive. It can take more drive. But you need to remember, this is biased also. So you do not have to drive this as hard. If you drive it like this, man, it'll sound great on sideband and last you forever. But we will drive it a little harder, just so you can see what it's doing when you drive it a little harder. Let me scoot this way. I thought I had a little bit more slack than that. Let me press pause. I'll be right back. All right, here we go. We got the Stickman Cobra 29 hooked up. 8 watts RMS. Swings to about 35, 40 peak, somewhere around there. So let's see what she's going to do. We're on 15 volts, 500 watt slug, PEP. Oh, God almighty, this cotton picker's stroking. Woo! Dog! We went from what? I can't remember what these were doing in the beginning. I have to go back and look. A Pride 100? I don't think so. I think you can go ahead and call this counting jobber a Pride 400, a 450, a 500 or something. That cotton picker is stroking. Oh, almost 500 watts. Son, let's see what the RMS is. Oh, about 175 or so, almost 180 RMS. Put that on a little bit better of a power supply, man, that thing will be doing 200 bird all day long. This thing is stroking, son. But you ain't got to run it like that, though, okay? You don't have to. Enjoy this bad boy. I'm going to clean this top for you, bud. And again, man, I want to thank you for hanging in here with me. I try to go the extra mile with these amplifiers. I ain't gonna lie, I spent about 3 days on this 2-pill. I know it shouldn't have took me that long, but I've had some other stuff going on and stuff. But it's hard just to go through this and not do anything. I even went in here and cleaned this thing up for you. You know, some people ain't gonna go that far. I went in here and cleaned this thing up for you as well. But like I said, I'm gonna go ahead and get this top right here cleaned up. Top's in fairly good condition. It ain't rusted too bad. You see there's a little sticker right there at one point. So I'm just going to spray this thing down and clean this up a little bit for you. And I guess I need to ask if you want these little things back or not. If you don't, I'll throw them in the transistor drawer for a possible repair in the future. I think I got maybe a few of these already in my big, well, it's not a drawer, but a big bag of used transistors. Actually, the thing's supposed to be down here somewhere. Here it is. All right, this is one of them. This is the one I keep out here. Yeah, see, a repairman. I ain't said technician. I said a repairman always needs to have some used transistors of many different kinds, because you never know. You never know. This is just a little that I keep out here. I got a lot more other places. Safety deposit boxes. I like to keep my transistors in safety deposit boxes. Just makes me feel safer. And if I ever, all I got to do is, while I'm out getting something to eat, just run into the bank and get what I need to get out. I was keeping all my Toshibas there, but I got the rest out because I only had like 16 left. And those are for builds. Mr. Captain Crunch and 2 other fellas. Alright, man. I just want to show this from every angle. And let me show it from this angle as well. Turned out very good, man. And we will show it from this angle. Alright, buddy. Hope you enjoy. Again, thanks for hanging in there. I know you waited a good little while for this, and I hope it lasts you for many, 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 many years. The GK, old gatekeeper, and Mr. Jack, a new fella in the family. This is Jack, y'all, Mr. Jack. Can you guess why he's called Jack? Leave it in the comment section if you get this far in the video. Why is his name Jack? First person to guess it right, you win 1,000,000 thumbs ups. 1,000,000 thumbs ups. Why is his name Jack? He's a good fella. You want to go get some Chick-fil-A? You want to go get some Chick-fil-A? He likes Chick-fil-A. Let's go get some Chick-fil-A, my friend. He likes some good Chick-fil-A. Yes, he does. All right, old gatekeeper right here. Love, peace, and chicken grease, and God bless. We're gone. Bye, 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 bye.